There are some differences between the different types of lead-acid batteries, but most share the same basic construction. An outer shell or container manufactured from polypropylene encases the battery's internal components. It also provides a protection from gas, oil, and impact. A vent or safety valve to relieve any excess pressure inside the battery from the chemical processes taking place inside. 2 terminals, one positive and one negative, that connect to the battery's internal components and provide the pathway for the battery's energy. The terminals are sealed to the shell, preventing leakage and reducing corrosion. Inside, partitions divide the battery into cells. Each cell produces approximately 2 volts, and the number of cells determines the voltage rating of the battery. So, a 12-volt battery contains 6 cells, while a 6-volt battery has 3. Each cell consists of lead plates that are positively and negatively charged and are stacked alternately, negative, positive, negative, positive, and so on. Separators made of either fiberglass or treated paper are placed between the plates to prevent the plates from contacting each other. The plates in each cell are connected at the top into positive groups and negative groups, and then connected in series to those of the next cell and then to the corresponding battery terminal. A battery is an electrochemical device that converts chemical energy to electrical energy. The chemical that brings a battery to life is a solution of sulfuric acid and distilled water called electrolyte. Electrolyte contains both negatively and positively charged particles called ions. It's the reaction between the electrolyte and the lead plates in the battery that sets off a chemical change and an exchange of ions, which in turn creates the electrical charge in the battery. During the discharge cycle, the negatively charged ions are transferred from the electrolyte to the negative plates, and then travel out through the negative terminal in the form of electrons into the electrical components of the vehicle, and then back into the battery's positive terminal where they're accepted by the positive plates. This process is reversed during the battery charge cycle, where the ions are driven out of the positive plates and back into the electrolyte, ready for the next discharge cycle requirement. There are many sizes, capacities and types of battery available. Yuasa manufacture 2 types of lead-acid batteries, conventional and sealed VRLA. Externally, both types of battery appear similar, but a conventional battery has filler caps and a vent hose, while the sealed battery has a removable sealing strip and a safety valve which is molded into the outer case. But internally, they're significantly different. The Yuasa technical manual contains more information on the internal makeup of each type of battery. Installing the correct recommended battery for a vehicle is important. Fitting the wrong product can cause battery failure and may lead to unnecessary warranty claims. Never install a conventional battery in a vehicle equipped with a sealed battery. They are different and are designed to meet specific requirements and needs. Some batteries are equipped with a sensor which will activate a warning light in the instrument cluster indicating when the battery is low on electrolyte. As a general rule, the sensor and the battery should be replaced at the same time. Yuasa publish comprehensive battery application and specification guides that cover all makes, models and year of manufacture for cars and light vans, commercial vehicles, plant and agriculture and motorcycles, which include ATV, leisure and marine applications. These ensure the correct Yuasa battery will always be specified. Please observe the safety precautions when working with batteries. Always work in a well-ventilated area and make sure there are no sparks or naked flames. Always wear appropriate eye protection, gloves and clothing. Clean up any acid or electrolyte spills immediately, and in the event that electrolyte may come into contact with eyes or skin, flush the area with water and seek medical attention immediately. A detailed list of safety precautions can be found in the Yuasa Technical Manual. Every new battery requires charging to reach maximum operational capacity. Using the proper charger is essential to the battery activation process. Several types of battery chargers are available. Constant current and charger maintainer types are recommended for battery activation. These chargers are professional quality and generally offer faster and more precise control of the charging process. Follow the instructions on the battery or use the equivalent charging options where constant charging is not available. Other types, such as trickle and taper chargers, are best used as maintenance chargers and are also suitable for domestic use. Always consult the instructions included with the charger for proper operating procedures. Be sure the charger meets the needs of the battery you're charging. Sealed-type batteries require a higher voltage charger than conventional types. Proper charging is essential to ensure maximum operational capacity and longevity of a new battery. It also helps prevent electrolyte leaks that may damage a vehicle. Failure to follow the proper activation procedures not only leads to premature battery failure, but also voids the warranty. As the procedures used to charge each type of battery are different, always check which type of battery you're dealing with before you begin. To charge a conventional battery, place it on a level surface, then remove the filler caps, placing them safely to one side. Remove the sealing cap from the vent and throw it away. Never replace this after the battery has been filled with electrolyte, as it may cause the battery to rupture. Fill each cell with electrolyte to the fill level indicated on the battery case. Always wear protective eyewear and gloves when working with electrolyte. The electrolyte should have a specific gravity of 1.265 and be between 60 and 86 degrees Fahrenheit. Leave the battery for a minimum of 30 minutes, gently tapping occasionally to remove any bubbles trapped between the plates. If after 30 minutes the electrolyte level has fallen, top up to the upper fill level. Replace the filler caps loosely and begin to charge the battery at 1/10 its rated capacity for 3 to 5 hours. Charging at a higher rate could damage the battery. Do not connect or disconnect the charger to the battery while the charger is switched on, as this may cause sparks that could ignite the hydrogen gas emitted from the cells during charging. Monitor the electrolyte level during charging and top up to the fill line as necessary. When charging is complete, turn off the charger and disconnect it from the battery. Push or screw down the filler caps as appropriate, making sure not to over-tighten them, and clean off any spilled electrolyte with a water and baking soda solution. Allow the battery to stand for at least 30 minutes, then load test it at 3 times its ampere-hour rating for 15 seconds, or use an automatic battery tester to determine the battery's condition, and then check the voltage. This should be a minimum of 12.4 on a 12-volt battery. The battery is then ready to be fitted. If the voltage reading is below 12.4 volts, or the battery fails the automatic battery test, loosen the filler caps and repeat the charging and test cycle. To charge a sealed battery, again place the battery on a level surface and remove the sealing tape covering the filler ports. Remove the electrolyte container from the box. Only use the container that comes with the battery, as it contains the proper type and exact amount of electrolyte for this specific battery. Detach the cap strip from the container and put it to one side. This will be used to seal the battery when charging is complete. The electrolyte container is made up of individual cells, each sealed at the top. Place it upside down into the filler ports of the battery. Ensure it's level and push it down to break the seals on the cells. Air bubbles should be rising in each of the cells, indicating that the electrolyte is flowing into the battery. If there are no bubbles, tap the container a few times, being careful not to tilt or squeeze it, as this may cause the cells to fill unevenly. Keep the container in place for a minimum of 20 minutes. Once empty, carefully remove the container and let the battery sit for 1 hour. After an hour, loosely place the cap strip over the filling holes and charge the battery according to the instructions included with the battery. Once completed, push the cap strip down using firm pressure from both hands until it's fully flush with the top of the battery. Let the battery stand for at least 30 minutes, then load test it at 3 times its ampere-hour rating for 15 seconds, or use an automatic battery tester to determine the battery's condition and check the voltage. This should be a minimum of 12.6 volts on a 12-volt battery. The battery is then ready to be fitted. If the voltage is less than 12.6 volts, or the battery fails the automatic battery test, repeat the charging cycle and retest the battery. Battery installation is a simple process, but incorrect fitting can reduce battery performance and life. If fitted, make sure the rubber dampers in the battery's tray area are in place and are in good condition. These provide cushioning from vibration that could damage the battery. Check the battery cables and connections for any corrosion or damage. Damaged cables or connections can cause charging problems that lead to battery failure. If installing a conventional battery, make sure the vent hose is properly routed. Failure to properly route the vent hose may allow gases from the battery to cause extensive damage. Connect the positive cable first, then the negative. Apply a light coat of grease to the battery terminals to help prevent corrosion. Then slip the rubber cover over the positive battery terminal. Reconnect the sensor if fitted. Install the battery holder bracket and tighten securely. Make sure that the positive battery terminal does not come into contact with any metal parts, as it may short to ground, causing sparks and risking damage to the battery. Secure any additional straps or ties used on the wiring loom where fitted and reinstall any parts you may have removed to access the battery. Although a battery may have been correctly charged and installed, it still needs to be maintained to deliver peak performance. Unlike cars, most motorcycles, boats and other watercraft, utility vehicles and ATVs are not used on a daily basis. When a battery is not in regular use, it will naturally discharge. Additionally, temperature and electrical accessories will also drain charge. Left unchecked, without regular maintenance, this can permanently damage the battery and void the warranty. For more information on the self-discharge of a battery, consult the Yuasa technical manual. To avoid warranty and replacement claims, it's important to advise your customers on how to get the best out of their battery. It's recommended that customers are made aware that monthly maintenance is essential to maintain the battery's warranty and required for both conventional and sealed batteries. This includes regular checks to make sure the top of the battery is clean and dry, inspecting the battery terminals, connections and cables for corrosion or damage, and ensuring all the connections are tight. The outer case should also be checked for cracks or signs of leakage. The routing of the vent tube on conventional batteries is correct and unobstructed. For conventional batteries, the electrolyte levels should also be monitored using distilled water to top up cells as required. Clearly explain the need to maintain a full charge in all types of batteries in order to avoid any damage that may be caused by the self-discharge process. Yuasa have a range of accessories and battery chargers available which can maintain the battery in peak condition. If the vehicle storage period is going to be long-term, the battery should be removed from the vehicle. In addition, the electrolyte levels and charge should be maintained throughout the storage period. If you suspect a problem with a battery, there are two easy and reliable ways to check its state of charge. The first is a hydrometer test. For conventional batteries, a hydrometer measures the specific gravity of the electrolyte inside a battery. There are two types of hydrometers: calibrated float and floating ball. To test the battery, insert the hydrometer into one of the filler ports, draw out some electrolyte, and take the reading off the hydrometer and compare it to the chart in the Yuasa technical manual. Test each cell individually. If any cell falls out of the specified range, charge the battery and retest each cell. If after charging any cell still fails to meet specifications, the battery must be replaced. The second test is a DC volt test. This can be done either unloaded or loaded. To perform an unloaded test on a conventional battery, connect a DC voltmeter to the battery and note the reading. Compare the reading with the chart in the Yuasa technical manual. If the voltage is below a full charge, charge the battery, then recheck the voltage. When checking a sealed battery, it must stand unused for at least 4 hours after charging in order to stabilize. Once stabilized, check the voltage with a voltmeter. If the voltage is below 12.4 volts, the battery needs recharging. To perform a loaded test on either type of battery, connect the voltmeter to the vehicle's battery with the engine off. Turn on all the lights and check the reading on the meter. A 12-volt battery should have at least 11.5 volts with the lights on. If the voltage is below this level, recharge the battery. Alternatively, there's a high-rate discharge test. This test uses a special device to apply a load of 3 times the battery's ampere-hour rating. After applying the load, measure the battery's voltage. A conventional 12-volt battery should have 12.4 volts, and a sealed-type battery should have 12.6 volts. If voltage drops below 11.5 volts during an unloaded test, specifically on a sealed battery, and the battery will not accept a charge at a normal rate, increase the charging voltage to a maximum of 25 volts for 5 minutes. If after 5 minutes the amp meter on the charger shows that the battery is drawing current, decrease the voltage to standard level and charge the battery for approximately 20 hours. If the battery fails to draw current after 5 minutes at the high rate of charge, the battery needs to be replaced. For more information on battery charging, consult the Yuasa technical manual. There are also a range of automatic battery testers available to test the condition of a battery. To ensure accurate results when using an automatic battery tester, always follow the manufacturer's instructions. There are variables to consider when charging a battery, including its existing state of charge and type of charger being used. Always refer to the charging instructions that came with the battery if they're available. If no instructions are available, the safe rule of thumb is to charge the battery at 1/10 the rated capacity for 3 to 5 hours. When charging a battery, ensure the charger is turned off before connecting to the battery. Always connect positive to positive and negative to negative. When charging a conventional battery, loosen the filler caps and make sure the vent tube isn't kinked or blocked. If the battery feels excessively hot during charging, stop charging it and let it cool. In this DVD, we've covered all the Yuasa battery basics to ensure that you and your customers get the maximum performance from our batteries. More information on our products, copies of all the application and specification manuals and the Yuasa technical manual are available from Yuasa and on the web at www.yuasaeurope.com.